using SQL Plus to start up the database. In order to start up your database, you have to connect to the database using sysdba or sysopar to start up the database. The first example, use startup command. Connect as SQL Plus and issue the startup command. Startup is equivalent to startup open. That means Oracle database will pass through all three stages: no mount stage, mount stage, and then open stage. This is the startup or startup open. Trying to start up your database till the open stage. This is meant by startup or startup open. You can only start up the database instance without mounting or opening the database by using startup no mount. Startup no mount means goes to the first stage only. Goes to the first stage, which is no mount stage, without mounting and opening the database. Startup no mount means startup only the instance, background processes, and allocating memory by reading the parameter file. You can also use startup mount. Startup mount means goes to the mount stage without opening the database. Startup mount, Oracle database instance first started and then mounted, reading the parameter file and start up the instance, and then reading the control files and mounting the database. This is meant by startup mount. In case you put your database in no mount state, to mount the database and open it, you have to use alter database command. Alter database mount and then alter database open. So if you start up your database by using startup no mount, that means your database instance currently started without mounting and opening the database. To go to the next stage or to go to the open stage, you have to use alter database command. Alter database mount to mount the database, and then alter database open to open the database. You cannot issue startup no mount and then startup mount or startup open. You have to go with alter database. If you do startup no mount or startup mount and you plan to mount the database or open the database, you have to use alter database command. In the previous slide, we discussed about the stages that the database goes through during startup and how to start up the database instance. In this slide, we will discuss the shutdown modes and how to shut down the database. There are 4 modes to shut down your database: shutdown normal, transactional, immediate, and abort. The first mode, which is shutdown normal. During shutdown normal, Oracle will prevent you from doing any new connection to the database, but it will wait until all transaction ends and all sessions end. Once all transactions and all users disconnected from the database, Oracle will start the shutdown. During the shutdown, Oracle will force a checkpoint and close the database files. Checkpoint means force database writer process to write dirty blocks from the database buffer cache to the database file, and force the log writer to write the changes from read log buffer to the read log files. The second mode, which is shutdown transactional. In shutdown transactional, also Oracle will prevent new connections, but it will not wait until the current session end. Once the transaction finished, Oracle automatically end the session. For example, if you have 5 connections connected to the database, once the transactions finish in each session, Oracle will automatically disconnect this session from the database and then do the checkpoint and close the database file and bring the database down. The third mode, which is shutdown immediate. In shutdown immediate, Oracle will not wait until the transaction end. He will forcefully do and roll back for all transactions from all sessions and then disconnect all sessions and then do checkpoint and close database files and bring down the instance. The last mode for shutting down the database, which is abort mode. During shutdown abort, Oracle will terminate the instance without doing any checkpoint or without closing the database file, which is terminate the instance. In shutdown normal, transactional, and immediate, Oracle do a checkpoint and close database files. During startup the database, again, there is no instance or crash recovery. While in abort mode, Oracle during startup will do a instance or crash recovery. For instance and crash recovery, it will be discussed later on in later chapters. Shutting down the database, there are 4 modes to shut down your database: either shutdown or shutdown normal, it's same thing, shutdown transactional, shutdown immediate, or shutdown abort. This is how to shut down your database. What is alert log file and how to view the content of alert log file? The alert log file similar to the messages log file for the OS. It is a log of messages and errors written out by Oracle database instance. Typical messages like starting up the instance, shutting down the instance, log switches for the instance, and some of the operation like resizing a database file, creating a table space, removing a data file from the database. All of these operations is logged and written to the alert log file of the database instance. So as a DBA, you have to check the alert log file for issues and errors for your database on daily basis. How to view the contents of alert log file? First thing, you have to locate the log file under your operating system directory structure. The alert log file stored under Oracle base, which is in our case /01 app Oracle, under diag directory, rdbms, database name or database unique name, instance name, trace / alert underscore orcl.log. In case you have a write, for example, this is the same location, user1 app Oracle diag rdbms, name of database orcl. In the first node you will see orcl1, for example, orcl1 / trace / alert underscore orcl1, because this is instance name, alert underscore instance name.log. In the second node you will see another directory 2, and this is alert underscore orcl2.log. This is the location and the name of the alert log file. The alert log file is a text file, so to view the content of alert log file, you can use any text editor you want to view the contents of alert log file. Under trace directory, there is a text version of the alert log file, and under /alert directory, there is an XML version of the alert log file, which is called alert.xml. This is the XML version of the alert log file. Under trace is the text version. Under alert directory is the XML version of the alert log file. In our case, I am using tail -f and location and the name of alert log file. Tail -f, it will view the latest 10 lines in the alert log file, and in case there is a errors written to the database alert log file, it will be automatically shown to the screen. In our case, this is the latest 10 messages written to the alert log file. For example, this is the alter system. This is alter system. Again, most important messages and operation happen to your database instance. It's logged in the alert log file. This is alter system, for example, or if there's an error during startup or shutdown, or if do a shutdown or start up your instance, all these operations are logged to the alert log file. So again, as a DBA, you have to, on a frequently basis, you have to check your alert log file content for any issues or for any important messages or errors. Oracle Data Dictionary, data about data or metadata, which is a list of tables that provides information about the database. These tables are stored inside the system table space and owned by sys user. So Oracle Dictionary is a list or set of tables that provides information about the database itself. There is a view called dictionary, which provides a list of all dictionary views in your database. For example, let's assume you create a table called employees. This table called employees has 4 columns: employee ID, employee first name, employee last name, and phone number. Each column has a data type. When you create this table, Oracle internally store information about this table. Who's the owner of this table? Columns this table has. What the type of each column? Is there an index for the column? Is there a trigger built on the table? This information about your object called metadata or data about data or data dictionary. This information is stored in a specific or specialized views and tables called a dictionary. The owner of this dictionary is this user and stored inside the system table space. To simplify reading from the data dictionary tables, Oracle built a dictionary views to display the information stored in the base tables of the data dictionary. These views decode the base table data into a useful information. So it's more readable than reading from the base dictionary tables. This is called dictionary views. Dictionary views either starting with DBA underscore, all underscore, or user underscore. User underscore shows everything that the user owns. All underscore everything that the user has privilege to see. DBA underscore shows everything. For example, there is a dictionary view called DBA underscore tables, another view called all underscore tables, and also user underscore tables. User underscore tables, for example, if you connect to the database as HR user and query user underscore table. User underscore table will show you all tables that you owned only. So if the HR user has employees and department tables, selecting from user underscore tables will return only employees and department table. All underscore tables, for example, returns all the tables the user owns plus all tables the user has privilege to see. For example, if you have an HR user and connected to the HR user, the HR user has two tables, employees and department tables, and he has a select privilege on a table, for example, system.test table. If the HR user select from all underscore tables, the select statement will return three results: employees table, departments table, and test table. DBA underscore tables, it will return all tables in the database. This is an example for a table. Same thing, there is a DBA underscore views, all underscore views, user underscore views. There is also DBA underscore indexes, all underscore indexes, user underscore indexes. The same thing. This is an example how to query dictionary views. The first example, select from DBA underscore tables. Select owner DBA table underscore name from DBA underscore tables where table name equal depth. So in DBA underscore tables, it will return all tables in the database. In our case, we are filtering table name equal depth. So it returns two tables. Table 1 owned by system user and table 2 depth owned by Scott user. In the second example, we are using DBA underscore tab underscore column. This view is used to return information about the columns inside specific table. So in our case, we are using select owner table name column name from DBA underscore tab underscore columns, where the owner is system for this table and the table name equal depth. It returns two records. Record 1 DID and record 2 D underscore name. So table depth owned by system user has two columns, DID and D underscore name. In the third example, we are viewing information about indexes created for the table called depth. Select index name from user underscore indexes where table underscore name equal depth. It returned one index. So table called depth has only one index, which is depth primary key. Last thing in this chapter, which is the dynamic performance views. Oracle contains a set of views that are maintained by the database server and accessible to the DBA. These views are called dynamic performance views because they are continuously updated while the database is open and in use, and their contents related to performance. That's why it's called database performance views. These views are owned by sys user, and the data of the performance views stored in the SGA. If you want to see a list of all dynamic performance views, you can select from a view called $fixed underscore table. $fixed underscore tables has a list of all dynamic performance views. Some of the database performance views can be accessible while database in no mount state. Some can be accessible also in mount state, and some can be accessible in open state. In this slide, we will see 3 examples of reading from a performance view. The first example is reading from view called $instance. This is a performance view called $instance. In $instance, we can query a list of information about the instance. For example, name of the instance, host or server name where the database instance is running, the status of the database instance, is it in no mount state, in mount state, or open state. If it is in no mount state, the status will return started. If it is in mount state, the status will return mounted, and if it is open state, the status will return open. The startup time, when you start up your instance, the last time you start up your instance. This is example how to query information about your instance by using the performance view $instance. In the second example, we are using $session performance view to get information about connected session to the database. Select session ID, username of the session, and the machine from where the session connected to the database. This is the client name. This is the client machine name. So in our case, we are using select SID, username, machine from session. You can put a filter, for example, where blocking underscore session is not null. In this example, we are returning only blocked sessions. We will talk about locking and blocking in later chapters. So in our case, we return session 46, user system machine is DB12C. In the third example, we are reading some information about the database by using $database performance view. Select name of the database, open mode of the database, and database role from session. This is the name of the database. Open and read write. It can be read write or read only. Primary mode, either primary or standby. In case you have a DR site, the DR database will be in standby mode. So in this chapter, we describe database initialization parameter. We learned that there are 2 types of parameter files, either binary, which is SP file, or text, which is initialization parameter file. And we discussed that there are 2 types of parameters, either static parameter that can be changed by scope equal SP file, and to take effect you have to restart your instance. And there is a dynamic parameters. Dynamic parameters can be changed either in both memory or SP file mode, and there is no need to restart the database in case you use memory or both. And we discussed about the stages of database startup. During startup your database instance, Oracle goes through 3 stages. No mount stage, reading the parameter file. From no mount to mount, reading control files. From mount to open, reading database files and read log files. And we describe database shutdown options. There are 4 modes for shutting down the database: normal, transactional, immediate, and abort. And also we discussed about the alert log file and how to locate the alert log file and view the content of alert log file. And also we describe the data dictionary and dynamic performance view. In the practice, we will see how to view and modify the initialization parameters, how to start up and stop the database instance using SQL Plus, and how to view the content of alert log file, and last thing, how to work with data dictionary views and dynamic performance views. I hope this video was informative for you, and thank you for watching.